Hello, welcome to MathCat and another third grade lesson. This one is going to be about arrays. This one will be a shorter lesson that follows from the ideas we talked about in the equations video. Make sure you watch that one before watching this video. Let's get started. An array is a group of objects that are arranged in rows and columns. Rows go across, so side to side, and columns go up and down. Arrays help us count and multiply faster. So if you look at this picture with the stars, we could count these individually, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We could also just draw a line of stars without putting them in this row by column kind of grid and just count them that way. But there's a faster way that we can count, especially if we have a lot more objects than this, than just 12. We need a more efficient way to count these. And you'll also see this arrangement in real life, like with tiles on a floor, and you need to know how many tiles are present. You could just count the tiles one by one, but if there's a lot to count, you might need a shortcut, or you might want to find a faster way to count them. And knowing this way of counting faster is a handy tool to have in your toolbox. So for example, there's 3 rows and 4 columns. We can just multiply the number of rows, which are 1, 2, 3, by how many columns, which are 1, 2, 3, 4. So to find the total, you can just multiply row by column. So that's 3 times 4 equals 12. This is just a handy graphic to keep in mind when you forget which direction rows and columns go. So this just shows that rows run and columns climb. So if you forget, oh, is this a row or a column? Remember that rows go across and columns climb. I just want to spend a moment to connect 2 concepts that we've learned so far. In the previous video on equations, we talked about equal groups. So remember that equal groups are when you have the same number of objects in each group. So here we have 3 jars of 5 elements in each group. An array is just a way to organize those groups into rows and columns. Arrays is just a picture that makes it easier to see the multiplication. So it's just an easier way to draw it out. Instead of showing 3 jars of 5, it's just an easier way to say, okay, I got 3 rows and 5 columns, so that's 3 times 5. Both show the same math fact, the fact that you have 3 groups of 5. Arrays are just a neat way to draw equal groups by lining them up in rows and columns. So now you can see the connection between the 2 concepts you've learned in the last 2 videos, equal groups and arrays. So let's look at an example. Maya is planting flowers in her garden. She plants 5 rows with 3 flowers in each row. How many flowers did she plant? So using the concept of arrays that we just learned, the first step is to draw an array. So this is our picture here. We have 5 rows, 2, 3, 4, 5, and we have 1, 2, 3 columns. How many flowers did she plant? We could just count these one by one, right? But we learned a new trick that is much faster than just counting every flower in this picture. Now we're going to write an equation. We take the rows by the columns, so that's 5 times 3, and that equals 15. So that's the total flowers that she planted. Let's look at a second example. Leo stacked notebooks in 5 piles, with 4 notebooks in each pile. How many notebooks did Leo stack? So here we have The problem kind of described in terms of columns instead of rows, like the previous problem we had rows of flowers, but a stack makes you think more of a column. So you have 1, 2, 3, 4 notebooks in a stack. So drawing that out, we have 5 piles. So we have 1, 2, 3, 4, 5, and then 4 notebooks in each pile. So writing an equation, how many rows do we have? And I would actually say write an equation and label the drawing, because labeling the drawing will help you think about what equation you need to write. So how many rows do we have? We have 1, 2, 3, 4 rows. And we have 5 columns. I'm just going to put it down here. So we have the equation row by column. So that's 4 times 5, and we know that equals 20. So that's your final answer for this problem. Let's look at one more that talks about a concept that I discussed in the previous equations video, but we can kind of see that in action here. How do you solve this problem using the commutative property? Liam placed magnets on the board in 3 rows of 5. How many magnets did he place? So if you're going to solve this using the commutative property, remember the commutative property states that you can switch the order of the factors in a multiplication problem without changing the answer. So here we have 3 rows, and we have 5 columns. So our equation here would be 3 times 5, right? If we're going to use the commutative property, we want to switch the order of these. So we have 5 by 3. Well, that means we need to change our picture. So now we're going to have 5 rows. 1, 2, 3, 4, 5. And we're going to have 3 objects in each row. So you want to redraw the picture, flipping it around. And this now has 5 rows and 3 columns. So our equation becomes 5 times 3 equals 15. And that's how you would solve this problem using the commutative property. That's all for arrays. Now you know when you see problems dealing with arrays, how to solve those. If this was helpful, hit like so more math students can find it, and subscribe for more math lessons every week.